Okay. All right, you guys are good to go.
Okay, this is our water filter. Um, the people who participated were myself, Kensley Morris, Peyton, and Alyson. So why are we doing this? We wanted to filter water to make it potable out of reclaimed and located water on Mars uh, for future and possible human-powered missions. For our research, we took inspiration from different ideas and put them together, um, and, and we just decided what would probably work better. And yeah,
we use those pictures the most. We just kind of combined them.
I think that's a good layers to help with.
Our first plan we came up with was to filter out of the 2-liter bottles, which we ended up doing. And the second one was to filter with the machine jars.
The mason jars is going to be a more permanent option where it would have a water like tap.
Yeah.
That they turn on and off water and do that on a much larger scale. But just for the process purposes, we did it on a larger scale.
So these were all our like supplies that we used. We needed like a lot of testing stuff like Slim Depot for afterwards. The cards and stuff. We used the activated carbon sand and pebbles for inside for filtering it, so it's like what's on the inside of the 2-liter bottles, along with the cotton balls. Those are both on top and on the bottom, so like here on it and up here for when you can see it, and then fabric and all that other stuff.
Diagram. This is our plan. We actually wrote directly on the bottle itself with Sharpie, so we could mark off each layer to correct percent. And that's just what Alyson just went over with like sand layer, tested carbon, medium sand, just like pebbles, and like of course the cotton balls, fabric at the bottom, not top here.
These are just pictures of when we were making it. And this is the
reclaimed urine, like reclaimed water, urine, big urine.
That we use.
This is our tests as well as results on it. So for the urine test for before, or that there was activity was 68, nitrates were 0,
Yeah, it was one.
pH was 0.8. Phosphates aren't on there, it's on the next slide. And then salt was 1.
And others with on the left side right here are all the salinity tests we did.
So for the phosphates or extreme water we did was 0, and same with the urine water. We did the E. coli and polyflora bacteria tests on those little cards that you'll see in a moment. For the simple bacteria, there was 216, and for the E. coli, there was 324. These are the after tests for the P sample.
And this is just like an actual picture of it and what we did with the UV light. We ended up changing the UV light after.
We wanted to protect from the skin. So we created like a little cardboard box chamber. It just goes right over the segment with water. But that photo's there to show like the light.
Yeah, and this is the P sample after filtration. Right.
So improvements that we might want to make. We might want to make it really easier to take apart at the joint because sometimes you have like 2 people to open it and it's hard sometimes. Making the chamber bigger so we can put the whole entire thing inside of it, not just this part. And then put coffee filters in between each layer so it doesn't like settle and mix together.
You notice when you poured in the contaminated water samples, it would often push up deeper layers to the surface. So that might help with just intermingling and keeping everything organized. And that's it.
Does anybody have any questions?
Yes.
So why did you use cotton balls?
It was the finest material we could find.
We also
And
like build up the layers so they absorb it and then come out.
yeah, we noticed that it helped a lot at the base. So you just put one on the top because we couldn't exactly make a deeper layer at the bottom without removing all of the top stuff. We did do research, and that was one of the things that people started being talking about was like a really fine layer. Cotton balls was really heavy, just as so was like cotton rounds and like tissue paper layers and stuff. And we wanted to do cotton balls were the easiest, most efficient to pack it directly into the tip of the water bottle. It just worked for our purposes.
You guys had a picture of where you were figuring out which layers and how much each. How did you guys figure out the exact amount of each different layer?
Just research. Well, we eyeballed it for putting it directly in, but as for like how thick each layer should be, we did research on that. Like the fine layers are a little bit more important because of the way the filtration works. So we tried to put more of like the sand layers in and those really like fine particulate citrus layers. Where like the like pebbles weren't super important because we weren't putting in materials that had a thicker particle size than those pebbles.
Any other questions?
What did you say the difference was between the bacterial counts before and after?
Yeah. So before, we didn't put it on here. Before it was a lot bigger. It was just like how, yes, it was. But no more at least 500 per book.
And after we got it down to like 200s, like that.
Okay, and the only thing you used was a filter? Was the filtration system? You didn't use any kind of bacterial agent, like they use the UV light?
We have a UV light. We do have a UV light.
That's what this is.
And then you like eliminate.
Okay, I didn't get that part of it.
Oh yeah.
Sorry.
Yeah.
Okay,
That was one of the requirements that all of them have a UV component.
okay.
Yeah, to get rid of more of the bacteria, we probably should have left it in the UV light for a bit longer.
It's not so much what's length, it can be anything under or over 10 seconds, I want to say. It's mostly just how strong the light is in comparison to the water. So you want to work on like the best setup for the where the UV light is the most of the water. You know,
Any other questions? All right, please give the ladies a round of applause.
Pretty cool.